we're going to continue on and try to find how different strategy 1 is from strategy 2. And to figure out how different they are, we're going to use a confidence interval because it lets us add in some buffer, some margin of error to the difference that we find between the average score for each strategy. In order to get this data into StatKey, we need to have a categorical and a quantitative variable at every single spot for every situation. That means that when we look at strategy 1 and we see that 33 right there, we need to say the full story of that 33. So when we go to StatKey, what we're going to actually be typing in is strategy 1 is the categorical variable, the option chosen, S1, and 33 is the quantitative variable, the response in seconds. The next one, that 42 right there, is also from strategy 1, so that's going to be S1, comma, 42. And we're going to continue that on, so forth, for all of the strategy 1s, and then we're going to get down to the 73. And we're going to say strategy 2, 73, S2, 73. And that's how the data is going to be entered. So we're going to start out at the confidence interval for the difference in means, and we're going to start doing that right here. So we'll go to edit our data, and we're going to delete everything that's in there. And I like to do it S1, comma 33. You don't need any spaces. I think S1 is easier to type than typing out strategy. And if you were to type it all the way out and made a typo, that typo would cause problems in the analysis. So you'll go through and type all of this in. So go ahead and pause and do that. Alright, so all of that data is now in. I still have a header row, so I leave that checked because I left that intact. If you deleted yours, uncheck that. And what you'll see here on the original sample is you'll see all of the original data points from group 1 and from group 2. If I generate a sample, what it's going to do with the bootstrap sample is randomly pick, in this case there were 8 individuals in each group, so it'll randomly pick 8 from strategy 2, randomly pick 8 from strategy 1 with repeats allowed, which is why these distributions look a little different. And it'll find the average of each group, and that yellow little arrow is the average for each group, and that's where that is on the screen. Then it subtracts those two. It takes S1 minus S2 and plots the difference on the StatKey graph. If you generate many samples here, it's going to do that over and over, and if you hover your mouse or tablet over this, you will see that as I move my mouse farther across the screen, the two yellow arrows get closer and closer together until they're the same at 0, and then the difference is more the other direction. So they get farther apart as you get on the ends. And what this curve is suggesting to me is that there is very little difference between the two groups. And if I look at my original sample, one has an average of 55.5, the other one 55.3. Meaning that, at least with the types of numbers we're dealing with the standard deviation of these numbers, there's almost no difference. The two groups are almost completely identical. And so when I go ahead and drop the two-tail on to do a confidence interval, let's say I want a 95% interval, my interval ends up being between -15 and +16.2. So let's go ahead and write that down and see what that means. So here I have -15 to +16.2, and that was representing strategy 1 minus strategy 2. So that's what's being represented with that data there. The interval of the difference is always saying how different is the average score of strategy 1 minus the average score of strategy 2. And the reason that we have an interval is because we're not sure exactly what that difference is, but we are some amount confident. So in this case, we are 95% confident, which is one that we typically use, confident that and then we're going to go ahead and put in our context here, average time because we are dealing with seconds here. For strategy 1, is, and then we put in our actual interval, so -15 to 16.2 in our units, seconds, because our quantitative response was measured in seconds. And then we always want to be comparing. We want to say faster than, and then we want to compare it to the other option, in this case strategy 2. Strategy 2. So the average time for strategy 1 is -15 to 16.2 seconds faster than strategy 2. When I look at this, if I had to say, is this statistically significant? Is one statistically significantly more than the other? My gut instinct is no. And the reason is because this interval right here spans 0. 0 is included, which means that the possibility of no difference is a very acceptable part of this confidence interval. So whenever you have negative and positives in the same interval, generally you're going to say that there is no statistically significant difference. Now we're going to run our tests in a little bit with a hypothesis test, and we can answer that a little bit more clearly. But just looking at the confidence interval, my gut instinct is that no, there is not a statistically significant difference. But again, just when you're working with a confidence interval, there's a template on the web page that you can use to get a sense for how you write these sentences, but this is a pretty good start of what you do.